spend an hour or so just running through the major points from what we've done through the semester. There's nothing of any great importance on the slide, but you might want to be able to see them. So the format of the exam is very simple. There are 10 questions. You can choose any 8 of those questions. They're all worth the same marks. It's a closed book exam, so you can't take any notes or any books or anything with you. Make sure that you do not bring any electronic devices into the exam room. No phones, no smartwatches, nothing. Except for a calculator. You may need a calculator, and that's okay. Make sure it's just a simple one. You don't need any clever kind of calculator, just something that'll do multiplications and divisions and additions for you. Okay, so you've got 2 hours to do the paper. You've got 8 questions. You shouldn't spend more than 15 minutes on each question. And that gives you an idea of the maximum amount that I would possibly expect in answer to any of the questions. Some of the questions have got more than one part to them. Where that's the case, the individual marks for the individual parts of the question are shown on the question paper. So basically there's 8 questions, each one that you have to do. Each one is worth 10 marks in total. Some of them might be broken up 6 and 4, some might be 2, 5 and 3, whatever. So you know if the question's only worth 2 marks, I'm not expecting you to write very much about it. My advice about how to tackle an exam like this is you've got 15 minutes of reading time, so the obvious thing you do is to read the question and select the 8 that you're going to answer. You don't have to answer them in any particular order, so it's okay then, out of those 8 questions that you select, to then mark the 1 or 2 that you feel most comfortable with, and I suggest you start with those because it gets you into the process. And you don't, if it's a couple of questions that you're very comfortable with, you can knock those over in good time, answer them well, and you're then going to feel good because you say, well, I've already done a quarter of the paper, I've done 2 questions, I know the answers to those well, I must have at least 16 or 18 out of 20, and I'm well on the way towards finishing this exam comfortably. So that would be how I would do it. Don't waste the reading time. You have the green scrap paper that's provided. You can be putting down some notes about what you're going to write for the various questions. And then when it is time to start writing, you're ready to go. Don't restate the question, because that's just wasting time. Just put question 5 and get into the answer. Or question 7 or whatever it might be. Don't, kind of copy out the question again as the first part of your answer, because it's just a waste of time. There's no point. Make sure that you don't waste time writing a whole lot of stuff which is not actually answering the question that I've asked. You won't get any extra marks for it, and you're just wasting time. And there's no point in trying to write a whole lot of extra stuff in the hope that you might get an extra half a mark or 1 mark or something. Remember, this exam's only worth, 50% of the total marks anyway. So if you got an extra mark in a question, it's not even an extra mark. It's only an extra 5/8, 7/8, so 6/8, 3/4 of a mark or something once it's fitted into the whole, because you're writing out of 80. Each question is actually worth 8 real marks. So don't waste time writing things that you think might get you an extra bit here or there, because that may mean you're wasting time where you could write an answer to another question and get 5 out of 10, and that would be 5 times more useful to you than getting an extra 1 out of 10 for another question. Okay, that's about all I can tell you about the exam. It will be based on all the things that we talked about in this classroom. And I'm going to run quickly through some key points from those things that we talked about. So the key topics that we had, of course, we talked a good deal about 3D modelling, and that was as the basis of a wider discussion about building information modelling. We talked about measurement, particularly in terms of the use of different methods of measurement. We've talked about estimating for tendering purposes, so estimating from a builder's point of view. We've talked again about extra over, and it's been good to see, you know, I'm marking the major assignments at the moment. I'm a bit over a third of the way through, and the great majority of those that I've marked so far have priced and measured extra over correctly for the formwork in their concise bill. Some haven't. Some still don't understand extra over at all. You will have your assignments back well before the exam. My aim is to have them finished at some point through next week. Well, in fact, they'll certainly be finished by Thursday next week and be available for collection. One thing that's interesting to note is that, as I mentioned previously, I got 6 draft submissions from 6 groups of students who had obviously copied from each other or paid somebody to do the work and then copied it, and it was all wrong. The ones of those that I've marked so far have scored very badly, not because I've penalised them, but because they had no idea what they were doing. I don't know whether any of those people are here. They know who they are, and their work was very poor. I suspect they should have done a bit more work in the beginning instead of relying on somebody else's work. And the last thing that we talked about was the role of professional associations. So under the heading of 3D modelling and BIM, we talked about a number of key points that came out of our discussions. One thing is that 3D modelling software is not BIM. A company, let's say a firm of architects, can be doing all of their documentation, all of their design work using 3D modelling software like ArchiCAD or Revit, and they may not be doing building information modelling. Right? As I put up on the board, Revit does not equal BIM. Building information modelling is really a management process. There's no point, I'm recording this, the slides have got nothing much about them anyway, it'll all be in iLearn. You can take a photo of it if you like, but the recording will be in iLearn. Okay, so 3D modelling software, of which Revit is just one example. 3D modelling software is a tool that allows us to create models. It's not the only software used for creating models that are used in building information modelling, because other consultants, other than architects, also create models, and they can use other software to do it. The point is, with building information modelling, is that the different models that are created by different parts of the team have to be created in software which can access models created in other software. So we have to be able to exchange information within those 3D models in order for building information modelling to actually become a reality. Simply creating a 3D model doesn't, or a group of 3D models, architects may create a number of 3D models for a job, but that's not BIM. If they send those models to the other consultants and the other consultants can open them up and add information or take information from, then we're starting to talk about building information modelling. What you did in your 2 days of Revit was not BIM. Not even the beginning of, well, yes, it was the beginning of BIM. The very beginning of BIM. Because you created a 3D model of a building. If that was all we did, that would not be building information modelling. You could print a set of drawings from it. You could print the door schedule and the window schedule and all of those things. And you could print up some nice 3D pictures. you wouldn't be doing BIM, you'd just be doing some 3D modelling. Now within that modelling software you were using intelligent objects. And what do we mean by the term intelligent objects? Well, for a start, they're elements of buildings. Doors, windows, walls, slabs, roofs, staircases, columns, all those sorts of things. Why are they intelligent? One is because they, for want of a better word, they understand what they are. Well, they're not, of course, they're pieces of software code, but what's being coded into them is a system that means that a door, for instance, understands that it fits in a wall. You try to create a wall out in the middle of the out in the atrium there, for instance, where there's no wall for it to go into, you'd have to do something quite fancy to actually make that appear. The other thing is that when you do create a door and you click on the wall where you want the door to go in, the software actually automatically puts it into the wall for you. It fits it into the wall. Wall objects know what they have to do when you try to connect two together, although sometimes it's a bit tricky to get it to do it. When you get it right, they will actually join up properly as solid continuous walls and so on. And that's part of why we call them intelligent objects. The other part of it is that we can attach a lot of other information to them through the use of the properties box. So we can actually open up, if you click on an element, open it up and see all sorts of details about it, and we can add other information into the properties. We can attach other information to those objects. Once we have a set of models, and we talked about this in relation to a couple of projects about how many models there were, and we saw that on the Perth Children's Hospital project there were a couple of hundred models created by different parts of the design team. But we understood that these separate models could be integrated into a single BIM model called a federated model. Federated meaning something which is made by fitting together or putting together, integrating, connecting a number of component parts to make a single item. And I explained the term federation by talking about how Australia came to be a country rather than 6 independent states, because prior to 1901, less than 120 years ago, Australia wasn't a country as such. We didn't have an Australian government. The various states, New South Wales, Queensland, Victoria, etc., each had their own government, and we were essentially still governed overall by the British government. But in 1901 we became a separate country, and the states were federated into a single unit, which was the Commonwealth of Australia. So a federated model, using that same word, federated, is the bringing together of a number of three-dimensional building models, often created, well, generally they will be created by different consultants, so there'll be the mechanical engineers models, the structural engineers models, the architects models, and many others, which are federated, put together into one large model. But we don't work, everybody doesn't work on that large model because it's too big. It's too big, it's too hard to handle, it requires a lot of computing power, and there's an awful lot of information in there that is only of interest to one small part of the design team. They don't need access. The structural engineer does not need to have access to all the mechanical engineer's information. It just has no relevance to them, and so on across many of the disciplines. So that you need to understand what the term federated model is. Typically, on a big project where there are many 3D models, many building models, these will be federated perhaps once a week. It's an overnight process. The consultants send their latest version of their models to the BIM manager on a prescribed night, let's say every Tuesday night or every Thursday night or whatever it might be, and overnight a big computer will put all those models together, and that allows us to run those sort of diagnostic programs like Navisworks, which will look for clashes then between different elements in the different models. Looking, for instance, to find where air conditioning ducts have been drawn such that they're clashing with structure, or they're clashing with hydraulics pipes, drainage pipes or something. Right, that's the third last point there. That's what clash detection is. Should there be a question in the exam about clash detection, that's what we're talking about. I have had in the past answers to questions about clash detection where people start talking about disputes between workers on the site. That's a kind of a clash, but that's not what clash or collision detection is talking about when we're talking about something in a BIM environment. We're talking about electronically being able to check the different models against one another to look for places where there are physical clashes or intersections between different components of the building. So that could be a drainage pipe trying to go through a structural column, an air conditioning duct clashing with a sprinkler pipe, all those sorts of things. Drain pipes trying to go through footing beams. The list is pretty well endless. So going back up our list, in talking about 3D models, we looked at a short set of slides about the level of development. The level of development of the BIM models. And it really is of the BIM model in this case. Although it can also be applied to individual models, and the basic outline was that LOD 100 is the model at the point that is about equivalent to the completion of concept drawings or a concept design for a building. LOD 200 is our design development model. LOD 300 is when we've got the model to a point where we can print off a set of drawings, elevations and sections and plans and so on, which we can give to the builders so that they can tender for the job, so they can bid, put a price together and bid for the job. And they can actually start building work from those construction drawings. From the LOD 300 model, the drawings that we get from there are essentially construction drawings. But a lot of the detail that's required is not contained in the drawings at that point or in the model at that point. That's LOD 400 when we're producing shop drawings and other sorts of details that actually get down to the very detailed level of individual parts of the building that have to be made and fitted together and built into place to build the building. Well, most of what we call shop drawings, fabrication drawings. That's LOD 400. LOD 500 is when the model is complete and it's been updated through the course of the construction so that the model then represents accurately the building as it was built, and that model then can be handed over to the client for their facilities management people to then look after the building into the future. It also gives them a starting point if they're going to do renovations or modifications to the building in the future. And in that LOD 500 model, we would expect that the properties of items in the building, such as electrical equipment and air conditioning equipment, pumps, generators, all those sorts of things, would actually have information attached to them which would give the facilities managers a lot of information that they need about maintaining, keeping that equipment in good working order, what kind of maintenance is required, how often it's required, where to buy necessary replacement parts. Let's say you've got a piece of air conditioning equipment or a pump that has a filter in it. Filters need to be cleaned regularly, and then at regular intervals they need to be replaced. It might be that they need to be cleaned every 3 months or 6 months, and they need to be replaced every 5 years. that sort of information can be attached to those items in the model, and then the facilities managers can just check those things so that they know. They can then draw up their maintenance schedules so that they know what work has to be done and when it has to be done, and they can make sure that those works are carried out when they're needed, so that the air conditioning equipment continues to work in good order and condition, just like we do with a car. You know, a car has to go and be serviced from time to time. We put new oil in it, we tighten things up, we lubricate various parts, we change things like air filters and fuel filters and so on. It's exactly the same with air conditioning equipment, except instead of it being up to us, we have a little sticker on the windscreen of the car telling us when we need to do that. Well, it's a bit different in a building, so having that information in the as-built or LOD 500 model provides the facilities managers with the sort of information they need to keep their, not just the air conditioning equipment, but other parts of the building as well, keeps them up and running. So that's what LOD is, level of development. The reason that we've had this framework has been developed in recent years is that we had no way really of identifying what levels, what degree of detail would be in a model at certain points during the design process, or in this case really through the procurement process, from the very beginnings of the design. You know, the earliest models that are made are probably less than LOD 100, they may be LOD 50, which would be just the very beginnings of the outline of a model, the overall shape and size of the building, but with very little detail, very little development. By the time we get to LOD 100, we have a model that we would perhaps show to our client and say, well, here's, you know, this is the sort of idea we've got for your building, this is what we think it might look like, and you know, we have some preliminary ideas about materials and that sort of thing, preliminary ideas about the planning. And the client can look at it and go, yes, this is what I had in mind, this is the sort of thing I'm looking at. So then the architects go away and they add more detail into the model. They develop the model further up to LOD 150 and then up to 200, and again they may show it then to the client and say, well, here we've got some more detail in here now, we've developed the design a good deal further, this is what the sort of layout of windows that we're looking at, and we've pretty well know how our internal planning is going to be, where the various rooms will be and how large they'll be and so on. And so we keep developing that model because, if you remember, that one of the big differences between the way we used to do this work and the way we can do it in this sort of 3D modelling / BIM environment is that where we used to have sets of drawings that were produced at different stages, with a model we're continually just developing and refining and adding more detail to it, resolving issues, resolving problems along the way. And little by little we go from a very basic model right through eventually to a very detailed model ready for construction, and then more information is added to that through the preparation of shop drawings and so on, and then eventually as-built information that takes us through to LOD 500. The idea is that this single model, created, the federated model like this with the various models in it, is actually really the same model, but it's just being improved and expanded through the process. And that's why it's useful to have these defining points, such as LOD 100 and 200 and so on. And there are now, there's a sort of handbook that describes the level of detail that we expect to see in an LOD 200 model. That also can be related to when the consultants get paid part of their fee. When you've done enough work that the model has been developed to LOD 200, you're entitled to 15% of your fee. Now that would not work if we didn't know what LOD 200 meant and what sort of detail we would expect the consultants to have into the model by that point. Otherwise we wouldn't know when to give them their 15%. They'd like it as soon as possible, of course. We don't want to give them this part payment until they have actually produced enough detail about the design for them to have earned their 15%. and so on to level 300, and so on to level 400, and so on. So you should understand that concept of LOD. I would say one thing though, if you are answering a question about LOD, don't just reproduce the example about the chair. That is just an analogy, a kind of way of explaining the degree of level of information about a particular component, a particular item, just to show that it goes from the concept of we have a chair at LOD 100 or thereabouts, through to LOD 500, which says we know exactly what chair it is, we know who manufactures it, we know what model it is, we also know who we bought it from, what date we bought it, and any maintenance that might be required on it. So by LOD 500 we know everything about the chair and all the other information connected to about where we got it and when we bought it and so on. That's 500, going back to 100, all we said was there's going to be a chair. So think of something else, you know. There's going to be a balcony, LOD 100. By the time we get to LOD 500, we know everything about the balcony. We know how it's been constructed. We know what kind of balustrade it's got and who manufactured the balustrade. We know what kind of waterproofing it's got on it and what brand that was, and we know how long it should last before we may have to replace it, and so on. So don't just think about the chair. If you just reproduce that slide with the chair example, that won't do you any good, because it doesn't tell me that you've understood anything about LOD really. It just means you've memorised what's on a slide. You know, we expect a lot more at postgraduate level at a university in Australia than just copying down what was on a PowerPoint slide. You've got to show us that you understand it. Drawing coordination, we talked about how that's evolved from having individual paper drawings, and the only way that we could compare them and make sure that they agreed was by visual inspection. With complicated job with lots of drawings was just about impossible. And the fact that now that we don't actually draw individual drawings, but what we do is to print views of the models, that in that case the model itself really coordinates the drawings, because when you make a change in the model, you simply reprint your drawings and the changes are all there on all the drawings. So there's none of that messing about like we used to have to do of if we changed change the position of a door, we had to change it on the plan, we had to change it on the section, we had to change it maybe in an elevation, and so on. Because now the model really coordinates all of that by itself. It's not actually an activity that occurs anymore. It's just an automatic characteristic. It's just how the system works. And it is, definitely better than the old way. Because we should have no disagreement between one drawing of the job and another drawing of the job. If this one's showing door 52 in this position in an elevation, then on the plan door 52 will automatically be in the same place, unless one person's got a new version of the drawing and somebody's got an older version of the drawing. So we do still have to make sure that the people involved have the latest version of drawings. So that sort of drawing coordination still has to be carried out, but as far as agreement between the drawings, the different views, because they're all just views of the same model, they should be the same. So long as we do still have to make sure that if we change something, we don't just reprint the plan, we need to also reprint the elevations or sections where that item appears. Clash detection we've already talked about. Enough. Right? It's about physical clashes, not between people, physical clashes between components in the building, which we can identify from the models long before we get to the site and have actually started to install these things, and then find that there's a problem, that we're trying to install an air conditioning duct and there's already a column in the way. And in fact, that was one of the clashes that I showed you as an example in the slides from the Perth Children's Hospital. There was a big flat air conditioning duct coming down with a column sticking right through it, a concrete column going right through the middle of it. Now clearly that doesn't work for all sorts of reasons. The column would already be in place for a start, and then you'd have to somehow try to build a duct around the column. And anyway, that would partially block the duct. I mean, there's so many reasons why it doesn't work that it's not worth talking about it anymore, except to say that, you know, those sorts of problems, if we find them on site, and the column's already built, the mechanical installer has already turned up with this big duct already prefabricated from some shop drawings in a factory, they bring it to site, oh, won't fit because there's a column in the way. And then there's trouble. And cost, extra cost, time delays, disputes, everybody unhappy. But we can solve those problems, we can identify them, as I showed you in the Perth Children's Hospital example with the duct and the column. We can see that and go, ah, right. Either we talk to the structural engineer about whether it's possible to move that column a little to one side and what effects will that have on other parts of the structure, or we go back to the mechanical engineer and say, look, you've designed this thing to go across here, this big duct, but there's actually a column in the way, so you need to rework your design there so that you can work around the column that's already in place. And so that can be sorted out long before it becomes a problem on the site. Schedules such as door and window schedules, detailed lists of all the doors and all the windows and so on, are produced automatically from the 3D models. Door and window schedules usually, almost always, probably always, come from architects' models. Doors and windows are not really the concern of structural engineers or electrical engineers or hydraulics engineers. So door and window schedules, but again, they are generated automatically from the model. So if the model is up to date and correct, your windows and door schedules will also be up to date and correct. Now, a key point that separates 3D modelling from building information modelling as a process, right? And that is the concept of collaboration between different parts of the design team based on the sharing of electronic models. So instead of sending information about what the building is going to look like from the architect to the hydraulics engineer by sending a set of drawings, instead of that, the architect sends their Revit or ArchiCAD model. The hydraulics engineer can use their software, not necessarily Revit or ArchiCAD. They can use some hydraulics design software to open up that model that's been produced in other software and be able to open it with their software, do their work, load information back into their model, which they can then send back to the architects or to the BIM manager, so that then the architectural model and the hydraulics model, along with other models from other consultants, can be federated into a single BIM model, which, as I've said, probably happens maybe once a week, not every day. That sharing of information by sharing models and collaborating in the design team through sharing information through the models is what BIM is really all about. Right, so if an architectural firm says, yes, we use Revit, we do everything in Revit, we are wonderful, we are leaders in the field of BIM, but actually we don't give our models to anybody because we're much too jealous of our models. We just print off some drawings and send them to the other consultants. That's not BIM. They're doing 3D modelling, but they're not really involved in BIM. Key to BIM is the sharing of information in electronic, digital, 3D models, through virtual building models. Okay, so that's really covering the major points that we talked about to do with 3D modelling and BIM. Of course, we talked about the different methods of measurement. And let me say again, this is one thing that's been very disappointing in marking the assignments I've marked so far. I've lost count of how many people insist on telling me that the concise method is only good for large projects, the Australian Standards method is only good for small projects, and the engineering method is only good for Lord knows what. Right? I don't know how many times I've said the concise method is simply a cheaper, faster version of the ASMM. It can be used for any building of any size, from $1 million to $1 billion and beyond. Those two methods are for buildings. The engineering method is for engineering construction. I just marked one just before lunch. Somebody told me that the civil engineering method was perfect for civil engineering buildings, like civil engineering projects like high-rise buildings. Now, in some parts of the world, and I have to make an allowance for this, in some parts of the world, construction and construction management are treated as part of civil engineering, in America, for instance. But it's not the case in Australia. Civil engineering here means things, generally speaking, this is a bit of a generalisation, but it's not too far off the truth. Civil engineering projects usually involve a lot of digging, a lot of moving around of dirt and rock. Roadways, bridges, ports, airports. That's civil engineering construction. Building a high-rise office tower in this country would never be described as civil engineering. So, you remember in the second block on the last day, I showed you a few extracts from the drawings which are taken from the model of the new sports centre here at Bond, which is not so new now. I suppose we should stop referring to it as the new sports centre, but it's the newest one we have, even though it's nearly 2 years old now. In the set of drawings that there are structural drawings, hydraulics drawings, architectural drawings, precast concrete drawings, and there's a small set of drawings called the civil engineering drawings. That relates to the groundworks around the outside of the building, where they pushed the dirt around and made, changed the shape of the block actually. So that's civil engineering work on a very small scale. That would not be measured using AS181. That would just all be measured together in, I don't know what kind of bill there may or may not have been for that job. But if it were being measured, say, using the ASMM or the CMM, that external work would have just been measured as part of that. Well, AS1181 is designed to be used for measuring engineering construction. And that's why it's got sections in it. And I just gave you some extracts, but you have access to the whole thing through the library. And I mentioned in class when we first talked about it that it has sections in it to do with things, construction work that you will never find in a building, like a railway line, or a tunnel, or dredging work. Dredging work is where you get a big floating thing that actually digs out the bottom of the sea, or the bottom of a river or a harbour. And if you want to get a deeper channel to let bigger ships in, you get a dredge, and you scoop up the bottom of the harbour and take it away and dump it somewhere. They've been doing it up and down the coast here off the Gold Coast as part of a plan to try to reduce the amount of, actually have been over a couple of years, moving a lot of sand around offshore to try to reduce the damage that's done to the Gold Coast beaches when we have the conjunction of very high tides and high winds and big seas caused by cyclones. Even though the cyclone might be 600 kilometres away, we still get we still get the big waves and so on, which do a lot of damage to the beaches. So that's what dredging is. It's not part of building work, but there it is in the civil engineering method. So the ASMM and the concise method can be used for any size of building job. Building buildings. Whether it's this building or it's the Burj Khalifa in Dubai, 120 stories of it or whatever there is. Has anybody been to Dubai and seen the Burj Khalifa? Yeah, I've got to say, this is a sight to see. You look up and it just goes on and on and on and on. It's huge. On the other hand, the rest of Dubai, I think it's an awful place. That's just my opinion. That's a bit off the point anyway. But yeah, just getting back to the business about those standard methods. I mean, I've tried to stress over and over that there's nothing that the ASMM is only for small projects and the concise method is for big projects. This is just nonsense. And there's nothing in the methods that say anything like that or even suggest anything like that. Anyway, so we looked at the different SMMs and we considered, and you needed to consider this in some degree in your written reports about the amount of detail in those different ones. The civil engineering method in its own way has a lot of detail in it. It's just different sorts of detail because of the difference in the sort of projects that it's actually designed to be used for. It is also a much more flexible method because those that put that method together understood that civil engineering projects can vary enormously, not only in size and complexity, but just by their very nature. Building a big bridge is not like building an airport. Really. Building a highway is not the same as, it's got similar bits to it, but it's not really the same as building a railway. There are all sorts of things that are specific to railways that you don't do when you're building a road. So these things, the civil method is designed with a good deal of flexibility in it, and how you measure can be determined by what the project is like. Where the ASMM is much more direct. It's dealing with building work, which while buildings may vary considerably in the way they look and what they're made of and so on, how they function, a lot of things are not that different. If you're pouring a concrete slab, it doesn't matter whether you're putting it in a hotel, in an office, in a school, in an airport terminal, in a hospital, a concrete slab is a concrete slab. It's either on the ground or it's a suspended slab. And that's about it. So those things don't vary so much. So the rules and in fact, the rules for a lot of the concrete work, even in the engineering method, are pretty similar to those in the ASMM and the CMM. The CMM, though, we know, because it's designed to be a faster and therefore cheaper way to produce a build quantities for a building project, regardless of size, is that it reduces the amount of detail that we have to worry about. So it, for instance, doesn't ask for the area of concrete slabs. It just says, tell us how thick it is and how many cubic metres there are. And you don't, so it, it's a little less detail. And of course, with less detail comes a little more uncertainty about how to price. And we saw that illustrated very well when we looked at an example of a large builder's bill for 20 stories, so quite considerable project, 20 stories. I don't know what the actual price of that was. I would expect $40–50 million probably, given the sort of building that it was. And we looked at that builder's bill and we saw that different parts of it were measured in varying degrees of detail. The concrete actually, and a lot of the excavation work, was measured in much the same way as we would measure it if we were measuring using the ASMM. Except for some things which didn't get measured at all. Things like separating excavation into different materials, maintaining faces of excavations, Did anybody actually have a look at that link that I put into announcements in iLearn about the trench collapse in Victoria a week or two ago, where one worker was killed and another one was nearly killed? Did anybody have a look at that?
Was that in New South Wales?
Sorry?
Was it in New South Wales?
No, it was in Victoria, I think, in Ballarat, I think.
Oh yeah.
If you had a look at that link, you will see that the excavation was quite deep. All the sides that you could see were all nice and straight and solid without any support. But there was the risk. They decided to take the risk and not do anything to hold up the sides of the excavation, and unexpectedly there was something that was soft enough or unstable enough that it fell in. Buried 2 workers, they managed to rescue one and the other one died. It's a real risk and not one to be, though the builder will be quite possibly charged with manslaughter, because whoever was in charge of the job should not have allowed that excavation to be unsupported with workers actually down in the bottom of it. Obviously it was reasonably deep excavation, because it was, I mean, if you were only in a trench this deep and it fell in, well, you'd get mud in your boots and you might need somebody to dig you out, but it would be unlikely to kill you. But that excavation appeared to be more than a couple of metres deep, so if somebody was in there and it fell in on them and knocked them over, then one poor bloke got buried and they couldn't get him out in time. Okay, so going back to the builder's bill, so that's one thing that we saw wasn't measured in that builder's bill. It just said prices have to allow for any maintaining any support to the sides of excavations if it's necessary. Also for all costs associated with getting rid of, taking away what we dig out of the excavations. So none of those things got measured separately, they just had to be priced in. Where we see that we don't have that level of detail in the pricing, then the typical response is that we increase our rates to make sure that we've got enough money in there to cover whatever we need to do. Means I've had to write this on a number of assignments again, just to remind people, doesn't matter which way you measure it, the cost is still there. Just because an item gets measured in the ASMM and it doesn't get measured in the concise method, but it's included in prices, doesn't mean that the cost goes away. It means you have to put enough money into the measurement, into the items that you do price, to get your price up at least to the price that you arrived at in your ASMM. And just while we're talking about prices, I've just marked a couple of cases where people found supply prices for reinforcement on a website called Medallia Steel, I think it is. Anybody recognise that name? Your supply prices were huge, because that is not a company that supplies commercial quantities of reinforcement to building companies. That's for somebody who's doing a bit of building work at home themselves and they just need a few small lengths of reinforcing steel. It's about 2.5 times the market price. What they've got on their website, about 2.5 times market price. I did suggest in the question, in the brief, that it would be wise when you built up a rate to check it against the corresponding rate in Rawlinson's, and if your rate was twice what it is in Rawlinson's, then something is wrong, more likely, something is wrong with your calculation than with Rawlinson's. So I had people coming up where Rawlinson's gives a bar Rio price in Brisbane of about, I think it's $2,230 a tonne. I had people pricing bar Rio at $4,800 a tonne. Well over double. Other people used the wrong labour rates. They looked up rates in Rawlinson's, which were already charge out rates, and then added 80% on costs to them. I'm going to get a job as a steel fixer and go and work for their companies, because as a labourer, a largely unskilled labourer, they're going to pay me $140 an hour. Wow, I only need to work 3 days a week and I'll be rich. Steel fixers don't get that kind of money. It's largely unskilled work. Even plumbers don't get that much money, and they're highly skilled. So, there were a few little issues like that. Anyway, let's get back to our builder's bill. If you remember in the builder's bill, we had some sections which were measured in the sort of detail that we would expect to see if someone were using the ASMM. Then we saw some other bits where things got lumped together. Do you remember the example of the 1,500 square metres of formwork to the sides and soffits of attached beams? Any formwork class, and some of it's curved. You remember that? Had to be priced as a single item. 1,500 square metres of it, and you now know that a lot of formwork like that could be anywhere between $120 and $150 a square metre, which you've now seen from your pricing exercises. You know that formwork is very expensive. So you'd want to be careful if you were pricing 1,500 square metres of this formwork and you don't know whether it's class 4 or class 3 or class 2, and you don't know how much of it's curved. So that was, and then we got to the swimming pool items, which were of course almost impossible to price with any kind of accuracy. These would have been prices, they would have been priced simply to make sure that there was enough money, and it would have been priced generously, because the sort of items that there were just things like all the finishes to the pool and some vague quantity in square metres perhaps. They were taking measurements for lighting to the pools off display drawings, which were a coloured three-dimensional picture of the pool, a picture designed to show prospective buyers or users or how beautiful the pool area was going to be. These were not construction drawings at all. And yet the quantity surveyors had to try to get some sort of quantities from those as best they could. And then the estimators would have had to price as best they could, given the very little information that they had to go on. So this is all tied up with the question of how much detail there is in the measurement. Of course, we know that builders' bills are not measured generally in accordance with any method of measurement. Well, the one that we looked at, it was the very first item in the whole bill. It said, this has not been measured in accordance with the ASMM or any other recognised method of measurement. So there were no rules, things were measured however it suited the quantity surveyors, given the information that they had available and given the time that they had available to do the measurement. We talked a lot about risk. You're probably all sick to death of hearing about risk, but of course one risk, as I've just mentioned, is a very real one, the potential collapse of excavation. It's not very long ago that somebody died in such a situation in Brisbane, and now we've had another worker die in a similar situation in Victoria. In a country like Australia, as rich and as safety conscious as we are, this really is criminal. And these days in Australia, such a problem like that, probably the head of the building company actually will be held to be responsible for the death of that person on their site. And that could carry even. It's not in most states of Australia, this is still not treated as a crime. It is in the ACT, in Canberra. In the UK, for instance, they have what is called industrial manslaughter. Now, manslaughter is a crime if negligence is what's called a civil wrong or a tort. You can't be locked up for a civil wrong, where you can be locked up for committing a crime. And in the UK, if the head of a building company had somebody die on a building site and it was shown that that accident could have been avoided if proper supervision had been in place, and for instance the sides of the excavation had been properly supported so that it didn't fall in and kill that worker, the head of the building company could go to jail for manslaughter just the same as somebody who in a fit of rage hits somebody with a chair and kills them. You know, you get a bit drunk at the pub and you have an argument with somebody, it turns into a fight, somebody falls down and hits their head and they die. You can be locked up for manslaughter. You didn't mean to murder them, you didn't set out to murder them. Manslaughter is considered to be less serious because it's really accidental killing, but you still killed somebody. But now in Australia you may not get locked up for it, but you can be seriously prosecuted under workplace safety legislation, and that even can lead to jail terms, although it's not called manslaughter. So, but there's other kinds of risk that they're physical risks on the site. There's risk associated with documentation, how accurate are the drawings, how detailed is the information, is all the information you need there to construct the building, and particularly, is there enough information, there are the documents good enough that you can measure and price accurately or with confidence. There's also risk attached to measurement. How much time is available for measuring, for instance. And we talked a bit about the different degrees of risk attached to using a bill of quantities that's been provided by a client, provided to tenderers to help them prepare their tenders, compared to the tenderers being responsible for measuring their own quantities. And I think what we concluded was that there was probably no more risk in using the bill provided by the client, even if it was not part of the contract, because it's been prepared by a firm of quantity surveyors, they've had time to do the job properly, compared to the preparation of a builder's bill, which tends to be done quite quickly, because every day spent measuring is a day not spent refining the pricing. So that is a question related to the accuracy of the bill of quantities, whether it's the one provided by the client and paid for by the client compared to one that is measured by, either measured by the tenderers themselves or that they commission somebody to measure for them. And that led us to a discussion of whether a BQ provided by a client is part of the contract or not, and what effect that might have. If it's part of the contract, it's a guaranteed BQ, and guaranteed means that the client is guaranteeing that the quantities are complete and correct. Everything that needed to be measured has been measured, and the quantities are accurate. If the bill is guaranteed and therefore part of the contract, and something is found to be wrong, then the builder can make a claim. If it's something that would mean extra payment to the builder can make a claim for extra payment and they will be paid. If the bill is not guaranteed, i.e. not part of the contract, the builder uses it at their own risk, or we say for information only. And if something is found to be inaccurately measured or has been missed from the measurement, then the contractor takes the consequences. They have to pay. They will not get paid extra for what was missed because the bill is not part of the contract and they use it at their own risk. Okay, so they were the main points that we talked about under that heading. We also spent quite a bit of time talking about estimating from the viewpoint of, in some detail, from the viewpoint of contractors, not from the viewpoint of quantity surveyors preparing whole of project estimates for clients, trying to predict what the client will pay for their building. Contractors' estimators are trying to predict what it's going to cost the building company to build the project. And you need to understand about labour costs, and that's why I mentioned that thing about a few people that have used the wrong rates out of Rawlinson's for labour, rather than using the basic rate and then adding on costs, or just using a rate out of Rawlinson's that already had on costs attached. They've added on costs onto a rate which already has on costs, so eventually it means they've added on about 150% in on costs, or at least 100% in on costs. So you do need to understand the difference between those different rates. There is the basic award rate. That's the minimum amount that the government has said somebody in a particular job should be paid, and they're usually quite low numbers. You know, builders, labourers of various classes should not be paid less than a basic rate of somewhere between $25 and $30 an hour. Well, nobody's actually worked for that money anymore, probably. But then we know that there were lots of things added onto that. Two kinds of things really, all of which can be called on cost. One was all the various other allowances that an employee is entitled to, things like travel time and sometimes meal times and those things. Then there are other things that are costs to the employer, which are benefits to the employee, such as holiday pay, payments into superannuation for their retirement fund and so on, plus other things like payroll tax and workers' compensation insurance, worker cover, insurance, sick days, wet weather, public holidays, all those other things that make up on costs on that basic rate. And when we've added all those in, we get a net cost. That's what it costs, and that's the rate that we use when we are building up prices for a tender, because we're trying to predict the net cost to the builder to build the job. So we want the net cost of what we are paying, not only directly to the employee, but the other costs that we have to meet because we've got that employee. Things like work cover and superannuation, for instance. Then there's what's called a charge-out rate. And that's the rate that we charge for one of our employees. And I used the example, for instance, of a lawyer working in a law company. When you go to see the lawyer, it may be $200 an hour that you're paying. The lawyer doesn't get $200 an hour. $200 an hour is the charge-out rate. That's what the law firm charges you for their employees' time to work on your case, your problem. That's the charge-out rate. It may be that between what they pay to that employee, that lawyer that's working for them in the company, plus on costs, that might be $130 an hour. That's the net cost. The lawyer might be actually being paid $90 an hour. That's their basic rate. That's their what they get paid. 130 then is the cost including on costs. The charge-out rate of 200 actually then includes the profit for the company. They have people working for them. They don't give all of that. All of the income doesn't go to the people who work for the company that are hired by the company. They get some of that, and of course the company wants to make a profit. In that $70, of course, there's going to be the overheads of running the company. And the same applies to building companies. You need to remember and understand that difference between general overheads and job-specific overheads, which we call preliminaries. They're a bit further down. We looked at some basic unit rate build-ups, and you've had to do some of those in the assignment. For reasons I don't understand, some people build up rates for concrete and formwork, or tried to, when all you had to do was build up rates for reinforcement. But we did various of those for reinforcement and for concrete. You should now be able to deal with any question that I ask you about building up a rate for a certain kind of work. Only in the trades that we looked at, though. I wouldn't suddenly ask you to calculate a formwork rate, because we looked briefly at an example merely to illustrate that it's very complex to deal with formwork. So if there happens to be a rate build-up question, it will be related to the sorts of things that we did in class. And I'm going to put up another, if we have time we might do it in class now, just another exercise like that to make sure that you're comfortable with that, otherwise it will be an island. One of the things that we had to deal with in building up rates was to talk about wastage. Because we know that when we measure, and this is pretty much going to be true, even if we were measuring a builder's bill where there's no set of rules, we would put a note into the bill of quantities that we have measured net with no allowance for waste. We want to make that very clear, because there are no... If we've measured a bill using the Australian Standard Method of Measurement, we don't have to say that, because we say we've used the Australian Standard Method and it states very clearly that we measure net as fixed in position, so we are not measuring any waste. No? So it's up to the tenderers, the estimators, to allow for wastage. How much they allow is their choice. Now we know that when we're talking about concrete, for instance, getting the concrete from the concrete truck into position on the site, there is likely to be some wastage and spillage in various ways. And that can depend on how we're moving the concrete, whether we're pumping it or we're putting it into wheelbarrows or whatever, what we're placing it into. If we're placing it into formwork, which has been well made to the right dimensions, then we're not going to have a lot of extra. But if we're pouring concrete into trenches dug in the ground, we know that they're not going to be exact and we're likely to be pouring a bit extra concrete. Plus some gets left behind in the truck. There's some left in the pipes from the pumps. There's some that sticks to the wheelbarrow. There's some that slops out of the wheelbarrows and so on. So there's going to be wastage. It's going to be different amounts with concrete, depending on how we place the concrete and where we're placing it. But in other trades, there's also wastage concerns. If we're cutting fabric reinforcement, there's going to be some cutting to shape and there's going to be some offcuts that don't get reused. Bar reinforcement, however, will usually be cut and delivered already cut to size, and we really shouldn't have to worry too much about wastage. The thing we have to consider with steel, of course, is rolling margin. And that's, but again, it depends where you get your prices from. One of the things about that Medallia steel site that some people got their prices from was that it said nothing about rolling margin that I could find. I don't know whether anybody found anything on that side about rolling margin. But the point here is that because that's a company that's supplying only small quantities of Rio to basically, well, amateur builders really, DIY, do-it-yourself kind of, you know, if I decided I was going to put a new pathway in at my house and I wanted just a small quantity of reinforcement, I wouldn't go to one of the great big reinforcement supply companies because they deal in, you know, tons and tons and tons of steel for big jobs. I'd go down to Bunnings and I'd buy a bit of mesh reinforcement and I would pay much more per square metre for buying that from Bunnings than I would if I were buying a truckload of it from One Steel or one of the other reinforcement, what are they called? Anyway, there's a few of the other reinforcement companies. I can't think of any of their names offhand. Mesh and Bar, for instance. Or One Steel is another one. But, you know, those prices would be quite different. So, and for a home builder, the concept of rolling margin and the concept of 1 or 2% to do with rolling margin on bar reinforcement is something they wouldn't even understand, and it would have very little price implication. And in any case, the prices that a company like that one, Medallia, is charging, or Bunnings, is so far above the market price for large quantities of steel that the rolling margin is more than covered by the exorbitant price that they're asking for in the first place. It's a very different situation if you are a big building company and you are going to a reinforcing steel supplier to buy 100 tonnes of bars. That's a lot of money to that company that's going to sell that to you. There's a lot of competition on price, so prices are going to be down. Suddenly, 2% for rolling margin, if it's not included or it is included, makes a difference to the price. And if you got prices from 2 suppliers and one included rolling margin and one didn't, and you were buying 100 or 200 tonnes of bar steel from those people, you'd want to be very careful when you were comparing their prices, because 2% of $200,000 is a considerable amount of money. Right? 200, what did I say? 200 tonnes, that's over $1,000 a tonne. So let's say $250,000 worth of steel. What's 2% of that? Is it $50,000? Something like that. And if one included it and the other one didn't, you'd have to be very careful comparing the two prices, because one would have this extra on it, and you would eventually pay the extra 2% if the steel weighed in heavy because of rolling margin. So that's the sort of things you need to really start to get a bit more of an understanding of in regard to prices. What's included, what's not included. Where are you buying from? What kind of discounts will you get? And be critical about prices that you come up with. If you come up with a price for reinforcing steel of $4,800 a tonne, and you know that Rawlinson says it's more likely about 2,200, you need to ask some questions. Okay, wastage we've talked about. Labour constants, they're those figures like 17 hours per tonne to place and tie ligatures in steel reinforcement, or 0.1 of an hour per square metre of mesh reinforcement. But they're productivity factors. How much labour time is required to do a specified amount of a certain kind of work. 0.55 of an hour to place 1 cubic metre of concrete into trenches for strip footings and so on. They're labour constants. We can use them in estimating, but how accurate are they? Well, they're averages of averages across many jobs. All jobs are different. Sometimes it's harder to do the work because of the shape of the building, the shape of the site, access to the site, all sorts of things. So it may be necessary to adjust labour constants for things that are specific about the job that you're dealing with. So they're often the only information we have, but they have to be used with some caution in real life, because jobs are different and the speed at which work can be carried out will vary. It will vary according to what sort of equipment we're using, how many people we have, how well trained those people are, how experienced they are. There's all sorts of things that can affect the accuracy of these published labour constants. But as I say, generally speaking, they're all we've got. And they give us a reasonable rule of thumb. Given that materials are typically, in most cases, a larger component of construction cost than labour anyway, if we can get our materials costs right and our labour costs are reasonably close, we shouldn't be too far away from a good answer. Profit and overheads we've talked about, right? When we're preparing a price for a tender, it's a net price, and once we've got that net price, including preliminaries, we add on our profit and overheads. Preliminaries can be time dependent. That means how much they cost us depends on how long we need the item for. So for instance, how many weeks or months of hire for a site shed? How many weeks or months of hire for a tower crane? Fixed costs are those one-off costs. Putting up the site, providing and erecting a signboard for the site that says what the project is and who the builder is and all that stuff. We do it once. And there may be also a fixed cost. It may be separate or it may be included in that, for actually taking the sign down and taking it away when the job is complete. Temporary connection to the electricity supply, so that we've got electricity on site to run our power tools and so on. That's a one-off cost. The cost of the electricity we use is a time-dependent cost, because it depends on how much electricity we use over a period of time. You need to understand the difference, not only between general overheads and preliminaries, but also the difference between time-dependent and fixed cost preliminaries. And then the big concept that we talked about quite a lot, which is probably the most difficult part, the concept of pricing risk. And the general rule is the more risk we see, the higher we will price. And we looked at a very specific example to try to illustrate this concept of pricing the risk, where we examined a clause in the Australian Standard Method of Measurement about maintaining faces to the sides of excavations, where it says, the measurement rule says, measure in all cases, even to rock, whether any is required or not, in order that the risk may be priced. And that, we've just had this sad illustration of the risk that exists when we excavate and we have people in that excavation. There is a risk that it's going to fall in. So if we started to dig that trench or that excavation for whatever it was for that building. And we found that the ground was not as solid as we expected, and we decided we should put some support in there. If we had, it would have been measured in the bill, and if our tenderers, if our estimators had decided not to price it, and it's always a choice, the estimators always have the choice of whether they price an item or just mark it as included, meaning it's covered by other prices in the bill. If they've decided not to put any money in there and they find they do have to put something in place, it will be at the builder's cost. So they have priced that risk, they've assessed the risk as being minimal or zero, and they've put no money in for it. If they think there is a risk that they're going to have to put something in, even if they think they're excavating in rock and it's unlikely that anything's going to be needed, but they think, well, we don't want to take that risk in case we find we've got to spend some money to put some sort of support in place, so they will price it. Whether they put in $10 or $1,000 or $10,000 depends on how much risk they think there is. If they think it's a very low risk, they may price it at zero. If they think there's some risk, they might put in $1,000. If they think there's a high risk that they might be going to, or if they're pretty sure they're going to need to do it, then they'll price it at the actual cost that they think it will be to actually do that work, to put some temporary support in place, and of course to take it away later on. Look, it's easier to work in a trench that doesn't have things holding the sides up. If you're trying to lay a pipe in a trench and there's things holding the trench, you've got to try and get the pipe down, the threads of drill, people have got to step over these things, and it's much harder to work. It slows the work down. If we can just dig the trench and jump in there and lay our pipe, and it doesn't fall in, that's great. It's faster, it's cheaper, but what happens when it falls in? Even if it falls in, and you've got your pipe in half laid, and then the trench falls in, even if it doesn't kill anybody, then you have to go back and re-excavate it. You've already got pipe in there, you could damage the pipe. What a nightmare. So there's all sorts of risks attached to it, and whether we price the cost of holding up the sides of the excavation is a choice. The tenderers may choose to price it or not to price it, and what they are doing is pricing the risk. If they think there's no risk, they price low or zero. The higher the risk, the more money they put in. And that's the basic rule. The more risk we see in any circumstance, the more likely we are to add some extra money so that we're sure that we have enough money in there to cover whatever we might have to spend. That's a really a key concept to have in your mind. Extra over, as I've said, in the assignments that I've marked, and I'm a bit over a third of the way through them, so far most people, well, certainly more than half, have handled extra over well. They have measured everything into the up to and including class 3, and then measured extra over class 2, and importantly, they've priced the extra over at a sensible rate. Their general rate has been about $120 or $130 a square metre, and then their extra over rate was an additional $10 to $20 or $25 on top of that, and that's as it should be. One I marked had a standard rate of about $140, and then they had for the extra over a further $130. So the formwork suddenly was $270 a square metre, which is very expensive because they didn't price it properly. So the basic rule is you measure everything. Let's say it were excavation with some rock in it. You measure all the excavation, including the part that we think is going to be in rock. You measure it all as other than rock. You price it at the other than rock rate. Then you measure the rock part separately, and you price it at the difference between the higher rate, which is rock, minus the lower rate for other than rock. Pretty straightforward, but it traps a lot of people. But I think this group might be closer to having a proper understanding of it. Then we talked about the professional bodies. Who they are, what they do, and importantly, why would anybody bother joining one? Well, what they are, you now know, are associations of people generally in a single profession: lawyers, doctors, general practitioners, quantity surveyors, etc., building surveyors. The RICS is a little different, that it has a number of divisions. It's a much bigger organisation, which covers people in all sorts of surveying jobs, including land surveyors, quantity surveyors, people who price and value buildings and artwork and all sorts, and businesses and all sorts of things, as well as people who make maps. There's about 23 or 27 different divisions, including building surveyors of different types, who are members of the RICS. So it's a bit different. As is the Chartered Institute of Building. It includes project managers, construction managers, quantity surveyors and a few other things as well. Not as broad as the RICS. What do they do? Well, one of their primary functions is looking at the education of people who are going to enter that profession. Now that means, for instance, three bodies importantly here that recognise the course that you are doing. That's the RICS, the CIAB and the Australian Institute of Quantity Surveyors. They've all looked at our course and they've come every year to check that we're doing what we say we do. And that means that when you graduate you are ready to be accepted as a beginning member of whichever one of those organisations you feel like you want to join. They have agreed that the education that we are providing in this particular field is adequate and appropriate. And if you hold our degree, they say, well, you've done a course of education, which means you've got the basic education you need to become a quantity surveyor or a builder, a construction manager or whatever. So that's only one of the things that they do. They're involved in all sorts of other things like providing access to continuing professional development. That's helping people in the profession keep up with new developments in the industry that they're in. So, for instance, the Australian Institute of Quantity Surveyors over recent years has run a number of workshops and webinars and seminars to do with building information modelling. There's a lot of quantity surveyors out there in the quantity surveying profession who have been in the quantity surveying profession since well before BIM was even thought of. And certainly long before BIM started to be implemented widely in the building industry. So how do they keep up with those changes? Well, one thing they can do is to take advantage of the workshops and seminars and so on that are provided by the institutes, which gives them information to help them keep up to date and in touch with changes in the way the industry works and the way their profession works. The professional bodies do other things. They talk to government on behalf of the professionals, and sometimes the government comes to the professional bodies to get their input about matters that the government may be thinking about introducing regulations to control. Things like licensing or registration of building professionals, something that hasn't actually happened much in this country. You may remember me talking about how you have to be registered to be an architect in Australia, but you don't have to be registered to practice as a quantity surveyor. So being a member of a professional body like the AIQS is a bit like registration. It's a badge, a certification that says that you are considered to be a competent quantity surveyor. You've been assessed by the institute that you've done a course of study at university which prepares you for the profession, and then that you've had some experience in the profession and you know what you're doing. In the absence of any sort of a license being required to be a quantity surveyor, being a member of one of the professional bodies is a bit like having a license to practice, but it's not as official, and it's not something the government administers as they do with the registration of architects. So why would you join? Well, that's one reason if you were a quantity surveyor, because there is no registration. There's more basic things about why would you join. One is it's just nice to be part of, I think anyway, nice to be part of an association of people who are in the same profession, people with whom you have much in common because of the sort of work that you do. And I've listed some other reasons: access to services and assistance of various types, access to resources through their websites, access to continuing professional development and so on. So there's a bunch of reasons why you might belong. They're not that cheap to belong to, I have to say. You know, some hundreds of dollars a year to belong, but in the absence of any sort of a license, if you're a picker, if you're a quantity surveyor, it's well worth belonging to one of them at least as a signal to other people who might hire you, for instance, that you are recognised as being a competent member of the profession. And as I mentioned, some companies will expect you to be a member, and some companies, if you're lucky, the one you work for might actually pay your annual membership because they want it to be on your business card. You know, just saying Rick Best Quantity Surveyor, that's okay, but being able to say Rick Best AIQS MRICS Quantity Surveyor means, you know, he's a quantity surveyor and he's actually I'm FAIQS, a Fellow of the Australian Institute of Quantity Surveyors, which is a bit more senior member, and that on my business card, even as an academic, that tells people that look and say, oh well, he's a recognised member of the profession. As well as being an academic in that area, he's recognised within the profession as being a senior member of the profession. So that has its own benefits as well. Okay, I think to finish off we should do this little exercise because this would be useful for you possibly in the exam. It's the sort of thing that I've asked in the past. So I hope you can see that well enough. This is just a simple little unit rate calculation. So this is just a little bit of pre-exam practice for you in case you come across a question along these lines. It wouldn't be this question, obviously, whatever happened. So estimate the net rate for the placement of 32 MPa concrete in a 200 thick reinforced concrete basement walls. So they're poured into formwork, although they're in the ground, poured in formwork. Concrete's going to be placed using a pump. Work it out on the basis of 20 cubic metres of concrete. We've got a delivered price there for the concrete of $175 a cubic metre. You don't have to work out all the bits and pieces of the pumping because we're working on Brisbane prices here. So it's just a flat rate of $30 a cubic metre for the cost of hiring the pump and the quantity charge and the transport and everything. $40 an hour plus 60% on costs. The small plant, which in this case is probably nothing more than a vibrator or two, we're just going to allow $1 per cubic metre for vibrator running costs because we own the plant, and that means that the actual cost of ownership would be priced into the preliminaries. And I'm saying allow 3% wastage on concrete. These basement walls are below ground, but I've only allowed 3%. Why do you think that might be? What is there in the details that I've given you that would be a reason why I would use only 3% wastage?
Pouring formwork?
If I'm pouring into formwork, that's good. Although I did say previously that if you're pouring into formwork, wastage could be as low as 1 or 2%. These are basement walls. And we're pumping down into these things. So I'm thinking that I've allowed a little extra waste for two reasons, at least two. One is because we are pumping down into the ground, there's likely to be a bit of splash around, but also these basement walls are not necessarily going to be beautiful formwork made very nicely to size. If we're looking at formwork for a wall, which is going to be an off-form wall, this formwork is going to be well made and kept. These are down in the ground, a bit difficult to get to. Some of the formwork is probably going to be pretty rough. Some of the formwork may even be left in place. So it could well be that the tolerances in the formwork are a bit bigger. So 3% is, you know, a considered amount to allow for wastage. There'll be a bit left in the pipes, there'll be a bit left in the truck, a bit spilt, and probably maybe a bit extra in the formwork. So 3%, a little more than sometimes when pumping, but not as bad, for instance, as if we were pouring directly into trenches in the ground without any formwork. And what we said is productivity, the last point there, 1.3 hours per cubic metre to place the concrete into the walls. Now, you can either do that now, and you can ask me any questions if you need to do it, or I can just put that up into iLearn with a solution and you can do it in your own time, your choice. If you'd like, I would recommend you do it now so that we can talk through a solution in 10 minutes. This is the sort of question that you would not spend anything more than 15 minutes on in the exam. So, I'm going to give you slightly less than that. At 3:45, I'll work through a solution. I've got an answer, so it's pretty straightforward, and I hope that everybody's got this now. So I said work it out on a basis of 20 cubic metres. So our basic concrete quantity is 20 cubic metres at our supply price, plus 3% of this number for the wastage. Now, I did have a question which shows some good thinking. The question was, if we're adding in $20, that should have been 30, shouldn't it? Did I say 30 or 20? 30, sorry, my number's going to be slightly wrong because I put a wrong number in there. Should we be including wastage in that? It's a very small amount. We've allowed a nominal amount here on the delivery, which is where the real money is. This would be, even at $30 a cubic metre, 3%, what are we talking about? An extra $2 or something. Into the unit rate, it would be very small. Wouldn't be wrong to add it, but it's hardly worth worrying about. So we've got waste on the concrete. Then the labour to place, 1.3 hours times 20 cubic metres, 26 hours at $40, plus 60% on costs. Our vibrator, the ownership costs are included in preliminaries. It's just our running costs at $1 per cubic metre. And then, yes, this should be $30 here, and I'll fix that before I put it in iLearn. We should have 20 by 30 for that. This number then should be a bit bigger, shouldn't it? It should be an extra...
5889, I think.
Okay, so then when we divide that by 20, instead of being 5689, so it should be about $295 a cubic metre, or $290 a cubic metre, something like that. 290, I think. 295 $295 a cubic metre. So that's the only thing that I've got slightly wrong here. So that's a basic rate build-up. If you're not sure how that works, you need to look back at the examples that we've done, and I will correct this one before I put it into iLearn, so that you can get a bit more practice if you need to before the exam. So are there any final questions that I can help you with today? Or are we all good? Everybody happy? Happy. Okay, well, we'll leave it at that, and I'll see you on the exam day. I will let you know as soon as the assignments are ready to be collected, which I hope will be before the end of next week. That's certainly my aim, is to get the rest of them out of the way as quickly as I can. Okay then, we'll see you in a couple of weeks.